Hi guys, we're back to learn the chain rule. Last time we were able to talk about the differentiation process when you have functions that have operations on them. For example, addition, subtraction, multiplication, and division. You do know now the differentiation rules for a sum of functions, a difference of functions, a multiple of functions, and a quotient of functions. But if you can still remember from our discussion on the operations and functions, there is a fifth operation we call composition of functions, or circle. This time, we are going to discuss about the differentiation rule that applies when the function that we are going to derive has, or rather is, a composition of functions. So let's get started. Now, on your board, on your screen, you will see here what we call the chain rule, right? So we have here the derivative of f circle g of x is the derivative of f with respect to g of x times the derivative of g of x with respect to x. Okay. Now remember the terms, the vocabulary that we use when we have a composition of functions. We have what we call an outer function and an inner function. And when we say f circle g of x, we actually mean by it that inside f is another function g of x. Now, g of x is what we call the inner function. You'll see it there, while f of g of x is what you call the outer function. And then again, you can rewrite the chain rule then to be the derivative of f of g of x is the derivative of f with respect to g of x times the derivative of g with respect to x. Now, it is crucial when we are differentiating compositions of functions that we are aware what is the inner function and what is the outer function. So let's have a brief practice first before we move on, whether you still can remember how to identify the inner function and the outer function. For example, let's have number 1. Could you tell me what is the inner function and what is the outer function? Right. The inner function here is 2x cubed. And what's the outer function? If we consider 2x cubed to be something, let that be u, then the outer function is u to the fifth, something to the fifth. Of course, we do know that that something is 2x cubed. Okay? But just so you know, the outer function is u to the fifth. Let's have another example. What about this? Can you tell me what is the inner function and what is the outer function? Right again. The inner function is 5 minus 2x. And the outer function is something square root of. And when you compose them, that's why you get square root of 5 minus 2x. Let's have one last go. What about f of x is e raised to the x squared? Can you tell me what's the inner function and what's the outer function? Very right. The inner function is x squared, and the outer function is the transcendental function e raised to something. Of course, we do know that in this case, that something is x squared. Good. I'm very glad that you still remember how to identify inner functions and outer functions when you have a composite function. In the next video, we are going to learn about how to differentiate using the chain rule. But for now, bye-bye, till next video.